Okay, hi everyone. My topic for today is vector autoregressive model, VAR model. It's commonly used for multivariate time series forecasting. And I want to go over some terminology before introducing the VAR model because these four terms at first was very confusing for myself. So we have a univariable, univariate, multivariable, and multivariate. And these four terms are sometimes a lot of people confuse them for each other. However, simply put, when the word ends with variable, it means it's indicating the number of independent variables. And when the term ends with variate, it indicates the number of target variable or dependent variable. So for example, if we have four independent variables and one dependent variable, we can say this is a univariate regression analysis, however, also a multivariable regression analysis. So the reason I looked into this because the profit model, according to the paper, is that it's a univariate model. However, it also has parameters such as add regressor, which can incorporate other regression lines into the model as well. And when I looked into it, it seemed to be a multivariable regression, however, a univariate regression. So that's why I needed to confirm the difference between these two. And also the reason I came to look for VAR model is because the industry I'm working in, online marketing, there are a lot of variables that we need to predict, such as since it's a B2B company, we need to predict a certain variable for a certain company. And there were numerous predictions that had to be made. And with profit, I could only predict one target variable at a time, and having to train a single model for each prediction seemed a little bit cumbersome. So I wanted to look for a model that could predict several predictions at the same time, and that was a VAR model. So it was introduced by Christopher Sims in 1980, so it's a quite of an old concept, and it was originally introduced for a macroeconomic framework. And to summarize how it works, it's a statistical model that captures the relationship between multiple quantities as they change over time. So I referenced the basic concept from this YouTube channel, which was very beneficial. And the concept of a VAR model can be seen as predicting a sales of a fruit. So let's say we want to predict the sales for apple and banana. And if you look in the diagram over here, we have the sales for current month, AT and BT, and the sales for last month, AT -1 and BT -1. Could you mute yourself, whoever is making any sound?
Oh.
Thank you. So as the sales between different fruits can affect one another. For example, apple sales from current month can be affected by apple sales from last month, and banana sales from this month can be affected by banana sales from last month. However, these can also affect each other as well. Since they're in the same fruit category, apple sales from last month can affect banana sales for this month and vice versa. So based on this relationship, VAR model captures this relationship into an equation. So for apple sales, we have the same apple sales from last month and banana sales from last month, and the constants or coefficients and the error term. And same for the banana sales. However, the constants and the error term might be slightly different. So since this only predicts sales for last month and this month, this is considered as a VAR1 model. And since it's a vector autoregression, it can be also put into a matrix format. This is the same equation, just put into different format as a vector. And to summarize, different sales, apple sales or banana sales, can be combined as a fruit sales vector. And the coefficients can be also put into one constant. And ft minus 1 represents the fruit sales for last month, and the error term represents the error term for the total errors. So based on this equation, we can not only predict the sales for last month and current month, but also for different time periods. So for our X model, we'll be modeling for X time periods. And this is just extending the equation to a longer format. So if you see over here, there is t minus 1, there's going to be t minus 2, t minus 3, and eventually t minus x, and then the error term added at the end. And yep, this is the same concept, but just with different time periods. And this is how the VAR model was created to capture the different relationship between the different variables and the time lags. So yep, VAR model is composed of different endogenous variables and a number of autoregressive terms. And as I previously mentioned in the introduction part, endogenous variables is basically different independent variables, and the autoregressive terms as the different lags of the variables. So since we have two equations with 1, 2, 3 lags of the variables over here, we can consider this equation as bivariate VAR3 model. And to construct a VAR model, you can hypertune the model by selecting the number of lags. And to do this, commonly used criteria are AIC and BIC. And both of them uses common factors such as log likelihood, the number of parameters, and for BIC, number of samples is added. So AIC is a Akai keys information criteria, which is multiplying the number of parameters by 2 and subtracting the log likelihood multiplied by 2. So it's preferred if we have low AIC as possible, since it indicates we have high log likelihood with less parameters. And for BIC, another term is introduced, N, number of samples. So in addition to AIC, it's low BIC is also preferred. However, it indicates that it has a high log likelihood with less parameters and less samples used in fitting. So if you look at the chart over here, there are rows of different lags, 0 to 8. And the AIC score over here, if you look at the red line, 9.93 seems to be the lowest of all the lags. So in this case, we choose VAR2 model since it has the lowest AIC score. So that's how VAR model selects the number of lags. And there are also different criteria. However, most commonly used ones I found were AIC and BIC. And another way of tuning the VAR model is choosing the right variables. For example, for apple sales, do we really know if banana sales affects the apple sales? Testing that is a Granger causality statistics. And I'm not sure if I have included over here, but a Walden test is used. Simply put, we include the banana sales in one model and exclude the banana sales in another model. And we compare those two and extract p-value. And if it's less than 0.05, we can conclude that banana sales does help predict apple sales. However, it does not help predict Y. In that case, we will be excluding banana sales from predicting apple sales in VAR model. So that's how lags number and the types are selected. Types of variables are selected. And the way inference in VAR model is proceeded is by using simple ordinary least squares. And there are certain circumstances that has to follow. The first one is that the error term needs to have a conditional mean of 0, meaning even if the different variables change, the error term should not follow that trend. It should be independent and must have a mean of 0, whatever the variable should be. And secondly, the variables in the model should be stationary, meaning I think this applies to most of the time series modeling. However, especially for VAR model, it's important that the time series data has no seasonality or trend. And lastly, since ordinary least squares is very prone to outliers, it's important to avoid large outliers. So given these circumstances, we can go and forecast the future predictions. And for VAR models, it uses an iterative forecasting algorithm. So we have to compute the first time period's forecast for all variables, and then the period ahead of that, and the period ahead of that. So every step is computed until you have predicted all the time periods that you want to predict. And after creating the predictions, you can go over different evaluation methods. Granger causality test, I've already mentioned in the variable selection. However, it's also used in the evaluation part. And there's also impulse response analysis and forecast error variance decomposition. However, these two were another big topic, so I thought I should include that in another presentation. So I did not really go deeper into these. But basically, impulse response analysis is measuring the response of one variable to a sudden or temporary change in another variable. And forecast error variance decomposition is calculating the proportion of variance of each variable and how it affects other variables. So that was how to create inference and evaluation on VAR model. And this, since it's been about 40 years after this concept was introduced, it's already being used in a lot of fields. There are medicine, epidemiology, economics, biology, and macroeconomics. And to pick one of them, for example, in epidemiology, we can predict how COVID-19 interacts across different age groups. So based on how the count of past infections across different age groups was measured, we can predict the future future values by the previous relationship between different factors using the VAR model. And there are so many other cases that you can look into if you're interested. And that would be my presentation for today. Thank you.